Alrighty. It's a bit tricky, this live thing. Okay, I think I'm gonna try and gravitate away from this. Let's see if we can't go to a topic that is of appeal to another grade that is a bit higher. So alright, so I'm going to actually do some what is it? I'm going to look at some quadratic functions. Look at some quadratic functions, well, actually not quadratic functions, but hyperbola functions. Okay? Yeah, it's been a minute, it's been a while, it's been a second since we looked at some functions. So let's look at some functions. Specifically, we will look at hyperbola functions, because functions that are of hyperbolic type and the exponential types are sort of like they are the thing. So we're going to look at some hyperbola functions, guys. Hyperbola, and we'll explore these to a large extent. Okay, so first and foremost, with hyperbola functions, you have the form y is equal to a over x plus p plus q. Alright, that is the general standard form of a hyperbola function. It can also be written as ax plus k over x plus p. That's another form that you can get your hyperbola function in. Okay, so that's very important to note, right? That this can be definitely the case. And I can imagine that sometimes for some people, the hyperbola function can be hidden if it's written in this form. Okay, but this here is the generally known form of a hyperbola function in grade 11. Okay, so I'm just gonna do our hyperbola function taking it from grade 11. Okay, so that's very important to note that for your hyperbola function in grade 11, your form y is equal to a over x plus p plus q is the generally known form. But sometimes your hyperbola function can appear in this form, and you may be required to actually convert this form to this one. Okay, sometimes hyperbola functions in another way are referred to rational functions. Okay, rational functions. Okay, and that's very important to note, just the word or the term rational functions. Okay, so that's just another name or word. So yeah, so in grade 10, you were exposed to the hyperbola in this form. That's what you were exposed to. This was grade 10. Y is equal to a over x plus q. But then in grade 11, we extended the hyperbola form and we include p. All right. In grade 10, you mainly purely focused on that, and obviously in your denominator there was a x value, right? And there was no constant. I don't know why this Camera of mine always does this, but it does funky stuff. All right, so now something to note here, if we look at each respective part of the function. So y is equal to a. What do we know when a is greater than 0 for the hyperbola function? If a is greater than 0, then we can anticipate that we will find the hyperbola function located in, and this is very important, located in the, so we call in the Cartesian plane, we call this the first quadrant. And I just want to note that this is in the name of the fact that this here, this line here, we usually refer to it as the horizontal asymptote, okay? And then this here, the vertical line, would be called our vertical asymptote, given by the equation x is equal to 0. For grade 10, we always knew that our vertical asymptote was actually x is equal to 0, because an asymptote is simply a boundary line. That's what an asymptote is. A boundary line where the function is not defined, or you could say where the function is not found, or where the function is not possible. That's what an asymptote is. It's a boundary line where the function is not defined. You will never find the function represented on the asymptote. That's what an asymptote is. Okay, so your hyperbola has two asymptotes, two of them. We have a horizontal asymptote and we have a vertical asymptote. So in grade 10 specifically, you had your vertical asymptote given with the equation x is equal to 0. Why? Because if you look at the denominator of the function here, a over x, the denominator here, x, can never be what? It can never be 0. So that's where the function is not defined, where x is equal to 0. So we said, what is an asymptote? An asymptote is a boundary line where the function is not what? Defined. Where the function is not what? Not found. Where the function is not what? Is not possible. Okay, so that's our vertical asymptote, as I've just explained. Then we have a horizontal asymptote. Okay, so our vertical and our horizontal asymptote then expose us to what? To a first quadrant, second quadrant, third quadrant, and the fourth quadrant. All right, so with that in place, whenever we sketch our function, when the value of a here is greater than 0, then you can expect to find the function represented in the first and what? And third quadrant. You can expect to find the function represented in the first and the third quadrant. That's when a is what? Greater than 0. Expect to find the function in the first and the third quadrant. Okay, but when a is less than 0, then I'm sure you guys can think sort of like in the same vein. If the function is found in the first and the third quadrant when a is greater than 0, where will we expect to find the function when a is less than 0? Then you can expect to find the function in the second and the fourth quadrant. All right, so this is a very important aspect to note, that a here, this a value, which is the numerator value in our hyperbola function, our rational function. If this a is positive, expect when you sketch your hyperbola function, expect to find it in the first and the third quadrant. But when the a is less than 0, then you can expect to find that function in the second and fourth quadrant. All right, so this was just from the standpoint of a grade 10 learner. A grade 10 learner understood or understands that when your function, your hyperbola function, y is equal to a over x plus 2, when a is positive, function is found in the first and the third quadrant. A less than 0, hyperbola function is found in the second and the fourth quadrant. And then rightfully so, this would be our horizontal asymptote, and this would be our vertical asymptote, because those are the boundaries of the quadrants. They are made, your boundaries of the quadrants are made by the horizontal asymptote and the vertical asymptote. Okay, so guys, it's no different than in grade 11, because in grade 11 what we do is that with your function you still have the a. The a still says the same thing. When a is greater than 0, expect to find your function in the first and the third quadrant. When a is less than 0, still expect to find your function in the second and the fourth quadrant. But we introduce a new parameter in grade 11, and that is this denominator, which was usually an isolated x value in grade 10, now has a constant that is attached to the single x value. Okay, and that constant term can either be positive p or it can be negative p. All right, because this p value will affect the function in a certain way. All right, and we will look into how the function is affected when our p value changes. But for now, guys, I want you to note that from the grade 10 point of view, where the parabola was concerned, if our a was positive, we know the function is in the first and the third quadrant. But if our a is less than 0, the function is found in the second and the fourth quadrant. So in other words, this function is a decreasing function. When a is greater than 0, what we are finding is a decreasing function. In this quadrant, this function, as it moves from left to right, x, as it increases, what happens to y? Y is decreasing. As we go from left to right, our function is decreasing. It's going down, 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 down as we move from left to right. If you come this side, on this side of the boundary line, what is happening with this function? As we increase our x values, our y values are going down, down, down. You can see this function is going down, down, down. It's approaching this horizontal asymptote, but never touching that horizontal asymptote. Approaching it, but never touching. Approaching, never touching. Approaching, never touching. All right. These are some of the things that I really love, because even in high school, learners need to make sure that as girls and boys interacting in the school vicinity, the schoolyard, it is no problem to approach another learner and have conversation with them. But please don't touch another learner. There are boundary lines that need to be formed. We can never do what? Touch. An asymptote is a boundary line where the function is not defined, not found. It's not possible. So likewise, we need to also have asymptotes. Very important to have asymptotes, boundaries, boundary lines where people never touch within the school vicinity, so that we ensure that we retain the innocence that everybody has within the school context. So it's very important. These boundary lines, these asymptotes, our function approaches these lines but never touches. The function approaches the line, this boundary line, the side, but never touches. We must never touch, because sometimes there's danger in the touching of the function. It loses its identity. It stops being a hyperbola function the minute it touches the boundary line. So it must never touch the boundary line, the asymptote, the horizontal asymptote, the vertical asymptote. It can never touch that. So please, guys, very importantly, when A is positive, the function is found in the first and the third quadrant, and as you can clearly see, the function decreases. So it is a decreasing function. It's decreasing in this quadrant, it's decreasing in this quadrant. Look at when A is less than 0. The function is increasing in the second quadrant. It is also increasing in the fourth quadrant. So that means when A is less than 0, as the function is found in the second and the fourth quadrant, it is a perpetually increasing sort of function. Okay, so I hope we are noting these things. They are very key. All right, so none of us now should be confused about what is happening to our hyperbola. All right, yeah, it is increasing or decreasing. Increasing when A is less than 0, as you can see, but decreasing when A is greater than 0, as you can see. And in these quadrants, two arms, all right, in these respective quadrants. And remember the asymptotes, ensuring that there are boundaries, all right, never touching. Okay, now something else I want to bring to our attention is the Q value, this Q value. So the Q value for our function has an important role that it plays, the Q value. All right, so first and foremost, I want to note this thing, that when we consider the Q value, y is equal to q is an important equation because it is our horizontal asymptote. So if we ever are asked what is the equation of the horizontal asymptote, all you need to do is you need to look at the q value, but you must make sure first and foremost that our function is in the form a over plus q or minus q. Whatever the q value is, all right, will be the equation of the horizontal asymptote. So we always say y is equal to whatever the q value is. That will be the equation of the horizontal asymptote. In grade 10, we noted that being the case, right? And our q value also speaks to our vertical shift or translation of the graph. Okay. So when the q value here is a value that is greater than 0, then it's like we are implying that the mother graph of the graph shifted up by a certain number of units. Okay, so this is when q is positive. But if q is less than 0, then we say that the function surely must have been formed by having been shifted down by a certain number of units. Remember, q less than 0 means q is negative. Q greater than 0 means the value of q is positive. So q is positive, shift up. The entire function moves up. It's like when we say shifts up, the entire function moves up vertically. If we're saying q less than 0, shift down, the entire function moves down. Okay, so hopefully we are together here. So we are unpacking the aspects of the function. For grade 10, A being positive, we note first and third quadrant. A less than 0, second and fourth quadrant. The Q value here tells us two things. Firstly, horizontal asymptote. The equation y is equal to q gives us the horizontal asymptote of our hyperbola function. Then this q value also speaks to how the graph transforms, or how it moves vertically, how it translates vertically. How so? If q is greater than 0, we say that the function shifts up or moves up or translates up by a certain number of units. But if q is less than 0, meaning negative, then it means that the function shifted down or moved down by a certain number of units. So we must note that as well. Okay. So for my grade 10 learner, surely this here now gives you a bit more clearer perspective about what effect does A have on the function and what effect does Q have on the function, and what it means, what effect it has, what it means, what effect it has, and basically what equation it can give us given the horizontal asymptote of our function. What is an asymptote? Remember, an asymptote is a boundary line where the function is not defined or not found, where it's not possible. And these boundary lines for hyperbola function are unique in that there are two of them, and they are both very important. In grade 10, we not only had the horizontal asymptote, which is given by the equation y is equal to whatever the q value is, but we also have a vertical asymptote, which is given in grade 10 by the equation x is equal to 0. Why x is equal to 0? Because we have an isolated x value in the denominator, and we know that when we have a fraction, x cannot be, or 0 cannot be in the denominator, because when it is, it means that that particular fraction is undefined. In this situation, the function is not defined, and ultimately it just means that the function is not defined on the y-axis in our grade 10 syllabus. All right. In grade 11, the function, the hyperbola function, takes on or adopts a new aspect to it, and that is our p-value. All right. So the a still means what we formerly knew it to mean. A is greater than 0. If you have the asymptote, then what's clear to us is that when a is positive, the function is found in the first and the third quadrant. But if a is less than 0, the function is found whenever we have our horizontal and our vertical asymptote. The function is found in the second and the fourth quadrant. Okay. Then, followed up on that, remember this point, that our q, okay, still no different, speaks to what? The equation of the horizontal asymptote is given by y is equal to whatever the q value is, right? And it speaks to our vertical translation of the graph, or vertical movement of the graph. When q is greater than 0, it still means we shift the entire function up. When q is less than 0, it still means we shift the entire function down by a certain number of units. And then our vertical asymptote is something else that we need to note. This time around, we can see that in the denominator, we don't only now have, like we did in grade 10, an x value that is isolated. Now we have an x plus p or an x minus p. So whatever the p value is, because remember these can be any real numbers, p and q and a, but we're just speaking about general stuff. So our vertical asymptote now is actually always x is equal to, now please take note, you take this x plus p, you make it equal to 0, and then you solve for x and you check what is the x value that you get. Okay, so I'm sure you guys can see that if we take an x plus p, we equate it to 0, because remember, whatever value of p that will make the denominator 0, that's where basically we need to check is what is that x value that will make the denominator 0. So we take that x plus p, we equate it to 0, and then we solve for x. So look at this. X is equal to what? Negative p. So that means what? That means when x is equal to negative p, the function is not what? Defined. All right? So therefore we know that our horizontal asymptote will always be given by x is equal to whatever the inverse of the p value is. So it's always just a good rule to always take whatever is in the denominator, equate it to 0, solve for it, and that will give you the equation, the vertical asymptote of the hyperbola function. Okay, so that's very important to note. Our horizontal asymptote is always going to be the q value as you see it, but our vertical asymptote of the function is always the inverse of the constant term in the denominator. So what we can typically do is take the expression in the denominator, equate it to 0, and then solve for x. That is the equation of the vertical asymptote. And then I want to speak about what effect does p have. P is involved in the horizontal movement of the graph. Remember, what does horizontal mean? Horizontal means movement left and right. So in grade 11, that is one of the new things that we learn in grade 11. Our function in grade 10 did not move left and right. Our function in grade 10 only really moved up and down. So that's why in grade 10 we always spoke about the q value, because that was speaking specifically to the movement of the graph up and down. When q is greater than 0, moves up. When q is less than 0, moves down. Now in grade 11, we introduce the parameter. Okay, we call this a parameter. Q is also a parameter. These are all the aspects of the graph that affect the movement or the change of a graph. Okay, so basically P affects horizontal movement. And I want to explain further that if P is greater than 0, then we say that the function shifts to which direction? Okay, do people want to guess in the comment section? If P is greater than 0, guys, what do you expect will happen to the function? Will it be shifting in which direction? And I want people to comment. I'm going to leave space here. Function will shift in which direction? Okay, do people know? If P is greater than 0, the function shifts. If we're talking about horizontal movement, we're talking about movement of the function left or right. So now I'm asking, if P is greater than 0, in which direction will the function shift towards? Will it shift to the right or will it shift to the left? Lwandle Ngobese, Lwandle is saying to the right. Revolutionary greetings to you, Lwandle. Good seeing you in the comment section, by the way. Lwandle, I actually have a question for you. Why did you say if P is greater than 0, it will shift to the right? What is your thought process behind you saying it will shift to the right? I want to understand that. because what you understand will lead me to my conclusion, and then hopefully we'll be able to really take this in deeply. Okay, why did you say shift to the right when P is greater than 0? What informs you actually giving that response? Okay, there's everybody else that's in the live that's watching. Please, guys, make this time to interact and let me know what you guys think. It's a positive shift. MO, it's a tricky one. X plus P is the determining factor, so it's to the left. All right, so I see the two responses there. Loandle, I feel you there, and I will tell you that normally any learner who is seeing or hearing this for the first time, all right, when P is greater than 0, everyone will conclude and say it's a shift to the left. But let me put it to you that in actual fact, unlike what you think, and this is the word that I want to actually now introduce to you, counterintuitive. Counterintuitive. Right, quite a hefty word if you want to call it that. But the word counter in English is a word that means what? Counter. Counter. So counter is a prefix, you know, root words that come before a main word or the end word. It's like the beginning word. Counterintuitive means against, right? Against. Intuitive has to do with thought process, thinking process. So for instance, when I asked Loandle, if P is greater than 0, what is the horizontal movement of the graph that you are expecting or anticipating? In your head, what do you think? So Loandle naturally gravitated to thinking, since P is greater than 0 and it's a positive, then it must mean that we are moving in the positive direction of our number line, which makes sense, you know. But I want to suggest that our p-value is counterintuitive. So what you were thinking, Loandle, naturally, is actually not what happens when p is greater than 0. It is against your natural, instinctive thinking, thought process. And that is to say, it is suggesting that when p is greater than 0, instead of us thinking that it is shifting to the right, it is actually a shift to the left. Shift to the left. And that is something I want to make as a very strong and solid point, that when p is greater than 0, for horizontal movement, it's a shift to the left. Secondly, when p is less than 0, once again, what are you normally naturally thinking when p is less than 0? Okay, what is your natural instinctive thought process when you're talking about p less than 0? Is it a movement left or right? Okay, so it is obviously counterintuitive. So when p is less than 0, we say that the function shifts to the right. Okay, very, very important about the p-value. Counterintuitive. P greater than 0, shift to the left. P less than 0, shift to the right. Okay, so hold that thought. It's very important. Never let it go. Never let it go slow. Never, ever, ever, ever. Okay. All right. So you guys now have learned that our function in grade suite 11 is y is equal to a over x plus p plus q. All right. A still means what it meant in grade 10, and it still means basically that our function is found either if a is greater than 0, it means that the function will be found in the first and the third quadrant. A less than 0, it will be found in the second and the fourth quadrant. This p-value speaks to horizontal movement of the function. If p is greater than 0, we think it moves in this direction, but in actual fact, it's against what we think. So when p is greater than 0, our function moves to the left. If p is less than 0, the function shifts to the right. Our q value, on the other hand, has to do with vertical movement or vertical translation of the graph. Okay, horizontal translation, quadrant situation. Okay, so A has to do with quadrant situation, A greater than 0, as I said, A less than 0, as I said. Okay, here vertical translation, Q greater than 0, up, Q less than 0, down. Here P less than 0, right, P greater than 0, left. So that's like a quick summary about everything that has to do with our hyperbola function. Okay, at least up until this point. And please guys, our hyperbola function has two arms. So in a particular function that we're given, we have that function having or existing with two arms. Now the other thing that I want to touch on very quickly when it comes to our hyperbola is that there are two what we call axes of symmetry. There are two axes of symmetry, and they intersect where the asymptotes intersect. So there are two axes of symmetry, and those axes of symmetry, there's one that has a positive gradient axis of symmetry, which means, in other words, it's a straight line that is an increasing function, the positive gradient axis of symmetry, and then there is a negative gradient axis of symmetry. And it basically has a decreasing sort of like straight line. Okay, no problem if you haven't. Okay, yeah, so this is very, very sweet, eh? Positive gradient axis of symmetry. All right, Don't worry, notification. There are some people that have seen my face because they've been to my actual account where I socialize with people naturally and normally without having to be behind a screen where I'm teaching mathematics. This is for the purpose of the maths account, of course, because obviously I'm trying to retain a sense of, you could say, professionalism if you want, or just anonymity, which basically helps me to to just sort of like allow the mathematics to be the mathematics without being entangled with, you know, face and who I am and what have you. Okay, so there's the positive gradient Axis of symmetry, like I said. All right, and remember, since this is a straight line, or these are straight lines, then these are given in the form y is equal to mx plus c. Okay, so that's very important to also note. Black China, I am someone who is helping out high school mathematics students. So the scope at which I operate is within the high school context, you know, grade 8 to 12. So I do think there are people that have platforms where they help out university level type students. So I'm sorry. Yeah. So that's the form, y is equal to mx plus c. So obviously if the gradient will be positive, that means that, and I just want to suggest as well that very easily, if in grade 11 and 12, if the gradient is positive, in grade 11 and 12, the gradient is always positive 1. And if the gradient is negative, for our axis of symmetry, the gradient is always negative 1. So this we know for sure. Okay, for the positive gradient axis of symmetry, we're always having a positive 1. For the negative gradient of axis of symmetry, we always have negative 1. And so the only thing that is really required then of us is to find the value of c, so that we can then be able to do what? We can be able to find the equation of the axis of symmetry. All right, so yeah, I'm just putting that in there so that you guys can know that there is an aspect of that function that basically sometimes requires us to know the axis of symmetry. Okay, all right, then obviously there will be moments when we will have to interpret, you know, a function of that nature and all the other things. Okay, so what I'm going to do now is I'm going to actually show you how we sketch a hyperbola function by going through a practical example. So let us see how to sketch a hyperbola. Remember, what did I say, right? There are two axes of symmetry, and the in and they what? They intersect. Where do they intersect? They intersect where the asymptotes intersect. So in order to get the value of c, what then can you do? You can just use the, remember, you are going to have the horizontal asymptote and the vertical asymptote. Where those two asymptote intersects, that is where the positive gradient axis of symmetry and the negative gradient axis of symmetry, they pass through. So that means if you have the equation, let's say for instance you have the equation of the horizontal asymptote, let's say for argument's sake since y is equal to -3, and then you have the equation of the vertical asymptote, and let's say it's x is equal to 2, right? Then it means that what you can do is you can write the points where these two lines intersect. Okay, so that means the x will be 2, the y will be -3. So you can use these coordinates, substitute them into the function. Remember, the function will already have the gradient, so you'll have x plus c, and all you do is you substitute that 2 and that -3 into this function and find what? The value of x. So let me just be practical with this. This is x, this is y. So sorry, find the value of c. Substitute 2 here plus c. You transpose. Therefore, c is equal to -5. That would mean that the equation of the axis of symmetry, this one, the positive gradient one, will be x minus 5. Do you see that? Okay, so it's very important that, remember, as I said, the two axes of symmetry, they intersect where the asymptotes intersect. Okay, yeah. So like I said, the positive gradient of axis of symmetry will always be +1, guys. Like without fail, grade 11 and 12 gradient, it will always be 1. The negative gradient axis of symmetry will always be -1, right? So if you want even the equation of the -1, you will use the same points. This is the coordinates for the what? This is where the axes, this is where the two asymptotes intersect. Okay, because you know what the equation of this one is. That means your y value is -3. Here at this point, y is still -3. And then here at this point, x is equal to 2. So that's your coordinates, 2 and -3. So you just substitute those as well to the negative axis of symmetry. Remember, this is -3. That's -x into 2 plus c. Then you get -3. You transpose the -2, it becomes +2. Therefore, c is equal to -1. What's the equation? Y is equal to -x minus 1. Okay, so there it is. Medzi, the title, you can go to my bio. There's a link in my bio, not the WhatsApp channel. Though I must say the WhatsApp channel, when you've joined it, is very helpful because I tend to post the links of the YouTube channels there because they are clickable, right? The only downside to TikTok is that our links, if you put them up, generally they are not clickable. You can't click on the link whilst you are on TikTok and go to the YouTube channel. Go to the specific video of the YouTube channel that I'm referring to. You actually literally have to copy the link and go and paste it on your search engine. Then you actually are able to get there. But if you are actually on my WhatsApp channel, all the links, because videos that I've done, I actually like putting them there so that people can actually scroll through and click them and join and actually find them. So you can actually utilize that. But my channel's name is Maths is a Game on YouTube. Okay, I think I just exceeded 1.2 K followers, subscribers of late. So you can just find it there. And I've uploaded a lot of content there, like for grade 11s, grade 12s, grade 9s, grade 10. Yeah, the works, man. And so much of the live lessons that I've done here are already uploaded there. I've tried to really also sort out the work so that I have playlists that are for specific grades and also for specific topics that you can check out there. So please have a blast there, especially as you guys are revising term 1. There's a lot of term 1 content there. For the grade 9s, there's even videos that I've done last year, like for end of year papers. So if you're preparing for exams, you can check out some of the highly viewed videos that I did there. A March paper, also did a March paper before you guys wrote your March exams. There's the videos are very low viewed, to be honest, but I think there was one video that was 3.8k views, and it was a grade 9 related sort of a video that I did where I was revising a March paper before the control test. So I think for people that are obviously doing a build up, because guys, we need to be building up now towards writing our final exam. Some of you are going to be starting very early, just be in May already writing your June exam. So it's good to prepare and to do minimal build-ups. Okay, guys, let me get to sketching this hyperbola function for the grade 11s. Okay, so we're here. So when we sketch a hyperbola function, we need to first start doing planning. Now, I like this idea of planning. So first and foremost, let's look at the function. Is it in standard form? Yes, it is. It is in standard form in that y is equal to a over the expression in the denominator with the constant on the side. So it is in form. Then our a value, how is it? It is positive. So a is equal to 4, which means a is greater than 0. So in my head already, these are my vertical and horizontal asymptote, and I'm like, this should be in the first and the third quadrant. So already I'm beginning with the end in mind. I know how my sketch will be like. It will be like this somewhat, you see? Yeah. Then after doing this, then I can go ahead and find the what? The x-intercept. Before the x-intercept, let's first write down the equation of the horizontal asymptote and the vertical asymptote. What is the horizontal asymptote? My horizontal asymptote here will be, look, this is -1, the q value. Y is equal to this. So that means y is equal to -1. That is my horizontal asymptote. What is my vertical asymptote? I need to take this expression, x plus 2, equate it to 0, solve for x is equal to -2. This is my vertical asymptote. So that's where I start, guys. First establish what does the A say and what is the intended graph going to be like with your asymptotes in place. First and third quadrant. Write down your asymptotes. 2, that's very important. 2 is write down your asymptotes. Okay. 3, find your x-intercept and your y-intercept. 3 and 4. So x-intercept, we know our x-intercept, we let y be equal to 0. So let's go and let y be equal to 0. We say 0 is equal to 4 over x plus 2 minus 1. Now it's like we are doing term 1, solve for x, you know, for quadratic equations where we have we've got fractions. All right, so what we do is we can see that there's an LCD, which is x plus 2. What do we do with an LCD? When we have found it, we write down the restriction. We know restriction x cannot be -2, and then after that we take the LCD and we multiply the left and the right by the LCD. So obviously you're going to say x plus 2 times 0 is equal to 4 into x plus 2 over x plus 2. We know that's going to cancel, and we also say minus 1 into x plus 2. So we multiply each term in the equation by x plus 2. So we have 0 is equal to 4 minus, now -1 gets distributed, -x, -1 gets distributed to +2, we get -2. We want the value of x. So -x, 4 minus 2 is +2. We transpose the +2 over, it becomes -2 is equal to -x. Then we divide both sides by what? By -1. Therefore x is equal to +2. What is this, guys? It is the x-intercept. What are the coordinates? It's 2 and 0. Remember, we let what? Y be equal to what? 0. Then we found what? X, which is equal to what? 2. All right. Clear? Can I get an indication in the comment section that people are still alive? It would be so sad that I think people are alive, and I think I am live, and we are alive, but we are dead and we are sleeping. Australopithecus, Homo habilis, Homo erectus. Okay, awesome. Thank you, guys. 2-0, nice. So that's our x-intercept. Then after that, we go for y-intercept. All right, that's number 4. Remember, I just did number 3, which was the x-intercept. Now I'm finding the y-intercept. For y-intercept, we let x be equal to what? 0. Where is it? Let x be equal to 0. So we go back to the function. We let x be equal to 0. So y is equal to 4 over 0 plus 2 minus 1. Grade 11, if you are in grade 11, and 12 as well, because 12 needs to bring these back. Grade 12s need to bring this back in preparation for the June exam, because grade 12s are writing, also they're going to be writing grade 11 aspects in their June paper. All right, so they also need to call this to their remembrance. So it's 2 minus 1, which is 1. So our x-intercept, 1 and 0. Do you see that? Okay. So if I am now going to go and sketch the function, please take note of how I'm going to sketch the function. Are you watching the function as I'm about to sketch it? Is it something that you would like to see? Oui. All right. So first things first. I'm sorry guys, I just had a little bit of a cramp there in my leg. Okay. So first things first, we need to sketch the asymptotes. You see, there was a reason why we decided to make sure that our asymptotes are there, because we need to first establish the boundaries. Guys, I don't know if you're hearing this. In life, you need to have boundaries. I don't know how one lives their lives without boundaries. If you don't have boundaries in life, right, disciplines in life, you need to have disciplines in life. Why? Because disciplines protect you. They protect the precious aspects of your life. If you don't have disciplines, things that you've already decided a long time ago that you will never do, and you stick to them because you know what you are protecting yourself from, then you can ruin your life. All right, so it's very important to have those. And it's very interesting that to retain the sense of the identity of a hyperbola, so that the hyperbola does not lose its identity, we need to ensure that we sketch the boundary lines first, so that we can encase the parabola within the parameters of the boundaries. Right? And that's very key. That is so key. All right. So y is equal to -1. We need to go to our hyperbola. In our Cartesian plane, locate -1. This is where y is equal to -1 is. So we draw using our ruler. When you draw, make sure you put a ruler horizontally here, and then this is what you do. You have a boundary line. It's horizontal. Then what you do, you label it. Y is equal to, what's the equation? Y is equal to -1. Guys, this is your first mark. You get a mark for drawing a boundary line. You get a mark for drawing a boundary line. Second, a vertical asymptote is x is equal to -2. Where's -2? X is equal to -2. That's here. So what do you do? There you have it. There you have it. Then you label it. X is equal to -2. Hey bana. Right. So you can see from these boundary lines, we said our function will be found in the first and the third quadrant. Where's the first quadrant? The first quadrant is this part, this side of the boundary lines. This is the first quadrant. So I'm anticipating my sketch to be here somewhere. Okay. Yeah. I've labeled my asymptotes. Now let's go and look at my x and then y intercept, the values that I got. Okay, so I got 2 and 0. So let's locate where 2 and 0 is. 2 and 0 will be this side. Okay, you see that? 2 and 0. Okay, it's the x-intercept. It makes sense. X is equal to 2. Obviously, we let y be equal to 0. So it makes sense if you look at this. Then we went and found the y-intercept. What did we do when we were finding the y-intercept? We let x be equal to 0. But look what we did. We substituted 0. We found what the value of y is. But look, when we wrote the coordinates, what nonsense or rubbish did we write down here? Is this correct? Y is equal to 1, and then we say 1 and 0. Is this correct, guys? Can you confirm for me in the comment section how authentic this is, given this? Is it 1 and 0? Am I right, or maybe there's something else I should have done? Let's see in the comment section if people are asleep or awake. So it's correct when I say 1 and 0. It's fine. Are you sure? Right? Really? No one's saying anything. Ha! Quietness. Hey, Bana. Hey, I'm alone in this live. It's time for me to end this live. I'm gonna end this live, guys. If no one responds in 5 seconds, I'm gonna end the live. 5, 4, 3, 2, 1. Okay, guys. Cheers. I'm going. Hey, so people are not watching, yeah. People are not interacting with the content. People are just here. They are existing. Where did you respond? We responded. Namangazi ngiphunyuke kanjani. Hey, Namangazi, the dot. What is the dot? What does the dot say, Namangazi? Phunyuke kanjani? Oh snap. What is this? What's happening here? So what did you respond? Namangazi?
And we did put the dot. Plus there's some people here, like 9 people watching.
9 people watching. Alright, but like this one, Namangazi, ngiphunyuke kanjani. What happened here? Is this correct?
Yeah.
Ayini guys. Okay, guys, look. Y is equal to 1. My coordinates when I write them. What value belongs here? And then what value belongs here when I write coordinates?
The X and Y.
Yes, so my Y
It's
is equal
supposed
to
to be 0 and 1.
Thank you. That's what I wanted. I wanted someone to tell me that no, say you are very wrong. Okay, thank you. I really appreciated that. Namangazi ngiphunyuke kanjani.
Oh my goodness.
Yeah, what is up with the name Namangazi?
Namangazi.
Oh my soul. Is that your response? Now we ask.
Yeah.
Oh my soul. So you just came up with that random?
Yeah, randomly. Do you have extra classes?
Sorry?
Do you teach people like extra classes? Do you tutor?
Do I teach people extra classes? Yeah, that's what I'm doing right now, aren't I?
I mean, like personally, like
Personally,
one thing.
You want to be personally taught?
Yes.
Oh my soul, you want to be personally taught. What grade are you in, Namangazi?
I'm in grade 11 and failing maths so bad.
Failing maths so bad? Wow.
Ish. It's
what
tough.
An introduction. What an introduction.
It's very tough.
But I'm sure now you don't know most why you're failing maths so badly.
I might know.
It's all encased in the name. Namangazi. Namangazi is like Namangazi everything.
Yeah.
Yeah, but like what's happening? Like you term 1, what happened, Namangazi? Tell me about your term 1. How did your term 1 go?
I passed almost all my subjects, and then my lower thingies were like maths and physics. Maths was like a level 2 and physics was a level 4. The rest was like 6, 7. Yeah, just maths and physics. I don't know what happened. It's not looking good.
And then like how's the maths this term? Because I mean term 1 is obviously like a bit basic. Term 2, how has that been? Have you done Euclidean geometry?
For analytical geometry it's moderate, it's fine. Now we're doing theorems. We just started theorems today.
Analytical is kind, very kind. It's kind all the way to grade 12.
Yeah, it's not bad. Some questions are fine. Some need what I did in term one, and me, I don't know anything from term one.
Okay, and why is that? Why don't you know a lot from term one?
Mostly because like I was missing a lot of days. I missed school a lot, and um also my maths teacher in grade 10, literally I don't know what was happening, but hey, being a muso, I mean, at all. So
Yeah.
I guess I lost the basics, and then everything just went bad from there.
Okay. All right. Yeah, I see the question you asked about like lessons and stuff. Maybe just send me a message again on the side, like just in the inbox. I'll send you a text, contact details. We'll chat further. Did Namangazi just mute?
No, I didn't.
All right. So I was just saying that you can send me an inbox. We
Already
can
did.
chat on this. Oh, you
I
already
did.
did.
Mm-hmm.
Oh, like you mean during the live whilst I was busy with the live, or you mean?
Yes, like right now.
Sure, okay. No, that's quite fast. All right, then we'll take it from there.
Okay, thank you.
Yeah, yeah. Cheers.
Bye.
Thank you for helping clarify this. You helped clarify. If you didn't clarify Namangazi, what would have happened?
Yeah. Bye.
Cheers. Bye. Okay. All right, back here. Okay, so guys, there it is, eh? We used our x-intercept 2 and 0 and our y-intercept 0 and 1, okay, to basically sketch the arm in the first quadrant, okay? And that suffices. When we have 2 points, that's enough for us to be able to have that arm represented in the first quadrant. But remember, from what I had anticipated in the beginning, I'm not expecting only to have one arm, but I'm also expecting to have the second arm in which quadrant? In the third quadrant, which is in this space. So now the thing is, from my x and my y-intercept, I did not get anything for this side. So what I then do is I go to my vertical asymptote and I check. This is -2. What x values can I find for myself so that I can at least have a representation of the function in this third quadrant? So I am going to choose randomly any integer values. And I mean, since -2 is here and -3 and -4 follow suit before -2 and they are smaller than -2, I'm just going to utilize my calculator. Quickly take -3, substitute it here. 4 over -3 plus 2. Now -3 plus 2 is -1. 4 divided by -1 gives me a -4. -4 minus 1 gives me a -5, which means when I substitute -3, I get a -5. Where is the -5? -5 is going to be down here somewhere. So -5 and -3, where the two meet, that's where my first point will be. -3 and -5. Then I substitute -4. -4 plus 2. It's quicker if you use it with a calculator, guys. You'll take a calculator, you substitute quickly, you'll get the answer. Okay, so if I substitute -4 here, -4 plus 2 gives me -2. Then 4 divided by -2 gives me -2. And then -2 minus 1 gives me -3. So that means when x is -4, y is -3. So I mean, this is just a rough estimate of where the points possibly are. And all I do, guys, is do you see this? My third arm, my arm in the third quadrant. Okay? My arm in the third quadrant. And I just label the points there. -4 and -3. Here we have -3 and -5. And there we have it. Beautiful sketch, guys. Isn't this beautiful? That's my hyperbola. 4, as sure as it is positive, expected the graph to be in the first and the third quadrant. It truly is in the first and the third quadrant, right? Horizontal asymptote has been labeled. There it is, y is equal to -1. Vertical asymptote has been labeled, x is equal to -2. X and the y-intercept, there they are. Accommodated at least my first arm. But then I need for my second arm to have at least some points as well so that I can see how that graph develops in that quadrant. And there it is. And all I do then is label y is equal to 4 over x plus 2 minus 1. Done. Done. Sketched. Done. Delivered. I don't know what more you guys would want from a guy like me. Okay, let me sketch another one just so that people can be thoroughly convinced that that was not a fluke. Let's look at another function. Let's say we had g of x is equal to, let's see, -4. So let's look at when the function this time round has a negative in the numerator of the fraction. Okay, then let's say, so we plan first, and when we plan, we ask ourselves a is equal to -4. That means a is less than 0. So what are we expecting? We're expecting to have the function in the second and the fourth quadrant. That's where I'm expecting things to be happening. 2, horizontal asymptote. When I want my horizontal asymptote, where am I going? Right, I think I feel like I need a guest right now. You know, I want to chat to someone. I don't want to do this fly solo. Come on, someone. You can request, guys, and come on in so that we can chat about it. Unless, of course, you guys are, maybe everybody else in the house is, shh, we're sleeping. Don't speak. And maybe you're going to be waking up people. Or maybe you're watching the live under the blankets. It's under the covers. You know? The door opens. That's funny. Oh, here is the sea of all seas. Lontle, how are you, man?
I'm good. How are you, sir?
No, man, I'm doing awesome. I'm doing even better, man, to hear your voice. Yeah. So, my man, I want help here. I want help. I don't want to be a soloist. I want to have a choir. I want to lead a choir of people. So, would you mind tagging along? We got our value of a. It's -4. We established that a is less than 0 because a is negative. Then this is where we're expecting to have our function. We're expecting to have our arms in the second and the third. In the second and the fourth quadrant. You know. Now I need next step.
So, are you asking me what was the next step?
Yes.
Oh, so do we need to get the asymptotes, right?
Yes, yes. So from here, how do we go about it? I wrote HA, but horizontal asymptote. How do you get the horizontal asymptote?
The horizontal asymptote. So we're gonna make. So say the horizontal is the one that goes up and down, right?
Yes. It is.
So say, isn't it like P? So isn't it the value 2? So it means if it's
Okay.
plus 2, then we're going to say negative 2. And you said that word, I even forgot it.
Okay, let's note. So I'm wanting the horizontal asymptote, and rightfully so, as you've said, it's the one that goes up and down. Horizontal asymptote goes up and down. So we are looking specifically at which value when we're talking about horizontal asymptote.
Say, if we're talking up and down, we're talking about, we're looking at plus 1.
Yes, exactly. Amen. So what's the equation? Because I want the equation of the horizontal asymptote.
We have to make it the subjects of the formula, right?
Okay, so it's going to be, like, you're so close. So close.
So it's going to be 1 is equals to, so can I take a
So
look at it?
y is equal to?
So it's going to be y is equals to then we're going to put the 1 first, right? And then plus the fraction.
Okay, sorry, you were saying the horizontal asymptote will be?
Y is equals to 1.
Okay, so yes, it's supposed to be y is equal to 1. Just
Yes.
let's
Yeah,
just
and then
recap.
the vertical asymptote is going to be x is equals to negative 2.
Thank you, thank you, thank you. Right, there's a reason why I had to call someone up, because the thing is, I feel like sometimes what I do is that when I teach, sometimes I think I probably feel good about what I'm saying, but it's good for me, and maybe I'm losing a lot of people, and a lot of people are not really feeling like they feel good about what's just happened. So yes, horizontal asymptote, we always look at the value of q, which is the constant. If the function is in standard form, then we look at this constant, and that is basically the value of the horizontal asymptote. But then the equation is y is equal to 1. So it's y is equal to whatever the q value is. Vertical asymptote, as you said, Lwandle, you said it's the inverse of the constant value in the denominator. So the inverse of plus 2 is negative 2. So x is equal to negative 2 is the vertical asymptote. Thank you very much. The next step, what do we want to now find after finding or establishing what the asymptotes are?
The x and y values.
So the x-intercept and the y-intercept, as you have said. So x-intercept, we let what?
So we let y be 0.
Amen. We let y be equal to 0. So let's do this. 0 is equal to negative 4 over x plus 2 plus 1. Then we solve for x. Term 1 work. Term 1 comes back. How do we proceed?
We're going to so we're going to remove the 2 there. So basically, say the way you were solving it, you were finding an LCD, and then my network stopped there. But then I have my way which I can solve this algebraically.
Sure, go ahead. Tell me.
Let me. Can I get my pen here quick?
Please do, please do, please do. Nice, nice. I like that. Jordan, Salona. We've got Nichu, we've got Mihla, we've got Elaine.
Sir, you still here?
Yeah, I'm still here.
Okay, so sir, firstly, let's move the one to the other side.
I love it. I love it. I love that method. Yes, we move the one to the other side. Just done it.
Remove the 2, sir. So let's multiply both sides by the 2.
Multiply both sides by what? By the x plus 2, you mean?
And then we're going to expand that. We're going to multiply the brackets into by that -1.
Amen.
And then we and then we isolate the x, the negative x. And then we simplify that side, so it's going to be -4 plus 2, which is going to be -2. And then we're going to divide by negative, and then that's going to be x is equals to 2.
Amen. Epic. Thank you. I love that method that you've just utilized. Okay. It would have been my go-to method as well. But the reason why in the initial problem I actually decided to speak about LCD was to just bring learners to an awareness of what they did in term 1, that whenever they're dealing with algebraic fraction equations, find the LCD, put your restriction, multiply by that LCD to remove it, you remultiply each term by the LCD so that eventually you can solve for x. So it was just that concept, because in what I'm doing with the revision, I'm trying to also sort of like prick what you did last term so that people can actually wake up to that as well.
Yeah.
But I like this method. I love this cross multiplication. You isolate the constant, you cross multiply. It's easier, hey? It's to the point, straight to the point. Okay, y-intercept.
For the y-intercept, say we're going to make the x 0.
Definitely. 0 plus 2 plus 1. So we have -4 over 2 plus 1.
Plus 1.
And that gives us -2 plus 1, which is -1. So our coordinates are 0 and -1. I butchered the coordinates last time when it came to the y-intercept, so I can't do it the second time round. Okay, right. We have our x and our y-intercept. I think we are ready to approach the sketching of the function. So what I love is that with the planning that I did initially, I'm already anticipating that this is where this is how the outcome will be like. 2 arms, second and fourth quadrant. So let's first sketch our asymptotes as we always do. Horizontal asymptote is y is equal to 1. So 1 is here. Let's sketch it using our beautiful ruler. And my ruler is freehand. Y is equal to 1. We label it. Then we have x is equal to -2. We label him. Okay. And I think then now we are ready to actually use our x and y intercept and see what can actually come, what will be sketchable. So 2 and 0, where's 2 and 0? 2 and 0 is here on the x-axis. Then we have 0 and -1. 0 and -1 is where? Him here. which means once again, we are having a arm that will be sketched, but the other arm is lacking resources. I wonder what symptoms this boy is talking about, or this girl. Mihlabi, what manner of individual are you? Okay, then here, you remember what I said about this? If we didn't have x or y intercepts to represent these points, the points for the other arm, so what do? We can actually choose x values on this side of the asymptote. So I'm just going to choose -3 and -4 because they immediately are integers that are before -2. And I'm going to take these and substitute them in the original so that I can find what the corresponding y values are. And then locate those points, and then sketch them. Sketch through those points. So if I substitute -3, -3 plus 2 is -1, -4 divided by -1 gives you +4 plus 1 gives you 5. So that means our corresponding y value is 5 when x is -3. Then what about -4? -4 plus 2 is -2. -4 divided by -2 gives you +2, and 2 plus 1 is 3. So when x is -4, y is +3. So then all we do, make sure that the asymptote is never touched. Mark the points, -4 and 3, -3 and 5.
So, sir.
Arrow. Asymptote. Don't touch. Don't touch. Come close. Don't touch. Yes.
Yeah. So if there's one of the parabolas doesn't have any coordinates, like as you said, like it doesn't have any resources, is it a must for us to find some of those as you did, or can we just draw it empty?
I suggest and I recommend that you find the others so that why do you want to do that? You want to be able to see the shape of the function, all right? And you kind of want to have the best approximate of the function represented on the Cartesian plane. So it's always nice when you can find the other point. I know that in some cases examiners actually give marks when you actually indicate the missing points where there are none. So there's like a other point mark that you get, So I would really encourage it and recommend it. I always tell my learners that, guys, what's nice about this is that you can actually use that table method in your calculator. You know how you can say table, I think it's mode setup, but you select table and then it pops up the f of x. You could punch these in and then you could actually like find integers. You start, let's say at -4, you end at +4, and then you can just have the table of values. So instead of like working out this one by one as you've seen me do, you can simply substitute into that scientific calculator of yours. You can punch in this function f of x over x plus 2 plus 1. You can punch it into your calculator and then you can substitute a range of values from -4 maybe all the way to 4, and you can have them represented on your table in your calculator. I don't know if you know how to use that, how to use your calculator to find the x and the y coordinates.
Yes, I do, sir.
Yeah, so I would recommend that because you don't want to be wasting too much time substituting values x, and finding those values. I mean, you could do that from the get-go. and just have those available, so that yes, you're definitely going to make sure that your x and your y intercepts are represented on your function. Okay, but then additionally, what you want to have is that if there's an arm that has no points, you want to at least have a point there in one of the arms, so that you can at least have a rough idea approximately of how the function should be developing as you sketch it. Then we label it. Then we're done. Done. Right? Okay. I think, I think we've covered quite a bit of ground. There's just one other thing before I leave you, my good friend. I just want to speak about these two concepts, and then we'll call it a night. I wanted to speak about these two concepts in light of the two sketches that we've drawn. So the first concept is the concept of domain. Do you know what domain is, Lwandle?
Yes, the domain has to do with the x values.
X values, that what? What about the x values, if I may ask, Lwandle?
What about the x values?
Yeah, what about them? Like, what is a domain? I know you said it has to do with the x values, but can you tell me more?
No, I'm a bit stuck, sir.
Okay, so the x values, these are the x values where the function actually exists. For the x values, where does the function actually exist? That's what you're asking yourself. So from left to right, is the function existing everywhere? Or are there places where the function does not exist for x? Does that make sense?
Yes, sir.
So if I'm moving like this from left to right, let's say we are moving. You see everywhere where my pen touches the function, it means it's existing. Existing on this line. What happens on this line?
On that line, it stops, sir.
Yeah, it's not existing. The function does not exist. Remember, this is a vertical asymptote. And we said this is the value of x where the function does not exist, because this is our vertical asymptote. Okay, so the function doesn't exist. But what is the x value where the function does not exist? It's x is equal to what?
-2.
Yeah, but for every other x value before this -2, the function was existing, and it was existing everywhere. Infinity, negative infinity, it was existing. You know what I mean?
Yes.
Then this side of the asymptote, the function is existing. You see, because look, there's a solid line. Existing. It's existing everywhere. The arrow here is indicating that the function will exist infinitely to the right without ever touching the asymptote that is horizontal. So it will continue to exist. So in other words, can we then agree that the function actually does exist everywhere from left to right? In other words, it exists for every x value, except, what's the exception?
-2.
Yeah, you see. So that's why when we write the domain for this thing, this one here, the main, we say x is an element of real numbers. What does this mean? It means the values of x for which the function exists, it exists everywhere. But there's an exception. But this here is like saying but x cannot be what?
-2.
Yeah. So people say x is an element of R to indicate that the function exists everywhere for x. But this thing here is like saying but x cannot be -2. So that's our domain for this function. So the restrictive part is the boundary line. Yeah, because that function is disciplined. For the function to exist and to have identity, it must be restricted from entrance into this, I don't know, I could say it's a hellhole. This hellhole, if it dares enter into this hellhole, it ceases to retain its identity and exist. So it's very important that we make sure that it doesn't exist, because that's how this thing is able to retain its identity as a hyperbola function. Range. What is range?
Okay, so it means the range is the y values where the function exists.
Yo, buddy, I think you are too fast for your own good. All right, nice. So it's a y values where the function exists. You've got it down now. So that means now, what are we looking at? From the bottom. Started from the bottom, now you're here, from the bottom, as we are moving up, the function is its existence existing on this line, this horizontal line. Y is equal to -1. Y is equal to 1. Is the function existing here on the line?
No, it doesn't, sir.
No. But then above it, exists. You see, so the function continues to exist above that line and below that line, but not on the line. So when we write the range for this function, lol, what are we going to say? You tell me.
So we're going to say y is an element of real numbers.
Yes.
And then we're going to exclude +1.
Yo, hi chap. In the don't. 1 for the money, 2 for the show. Literal. Okay. DJ Luandle, I'm signing out. It was real. I think we had a nice introductory fun with the hyperbola function. We will obviously explore it more. I think this was session number 1, part 1 of a hyperbola function. At least now I can have something in the YouTube channel for hyperbola, because there was nothing. And there was someone who was harassing me in our group saying, hey, you must do kaloku. You started quadratic, but and straight line, and you left it in J. So do something. So I did something. Yeah.
No, thank you very much, sir.
Cheers, Lwandle. You sea of all seas, oceans of all oceans. All right, that was great. Thank you so much. The missionary, I see you there in the comment section, Baba. It was great you commenting there. Guys, let me love and leave you. It was good. I think it was a real good session. Nice hyperbola functions. Hopefully, yeah, we got something from today's session, and we will pick it up next time with session number 2, and we'll explore more and more. Continue to practice mathematics, guys. Needs practice makes permanent. Let's practice. Let's build up till the writing of the exams, and level 7 all the way.